5.3, add, subtract, multiply polynomials. So today we have a few goals. I can decide if something is a polynomial and state the degree and type. I can perform direct substitution and synthetic substitution. I can determine the end behavior of a polynomial from the equation of the function, and I can add and subtract and multiply polynomials. So, which of the following are polynomials? For the ones that are polynomials, state the degree and leading coefficient. So, for A, we want to look for the highest degree first. That would be 3x to the 11th, and that's because we have a degree of 11 here. So we're just looking for the highest exponent. And our leading coefficient is whatever's in front of that x to the 11th. So in this case, that would be 3. And if you're curious, this is called an undecic. Just like we have cubic and quartic and quintic, we can call this undecic for a degree 11. You won't need to know that. B, let's see if it's a polynomial. So we want to find things that have x to some power, and all the powers have to be greater than or equal to 0. So if we look closely at this, x squared, well, that would be considered a polynomial. This term makes it not a polynomial. And let's think about why. So if we rewrite -1 over x, it's actually the same as -x to the power of -1, because when we flip over this fraction, we get a negative exponent. You can't have negative exponents in polynomials. No negative exponents allowed. So that's out of the question. We also can't have fractional exponents, so go ahead and see if C is a polynomial. Looks like this term's good, this term's good, this term's good. This gives us a problem. X, or the square root of x, can also be written as x to the power of 1/2. They're the same thing. So this is not a whole number exponent, which automatically makes the whole thing not a polynomial. And D, we have 4x squared minus 9x plus 2x to the 5th plus 7. Everything looks good here. Even though this is a constant, it's a x to the 0, if you think about it. So, because x to the 0 is 1. So we know that this is going to be a degree of 5, because that's the highest one we see. And we could call that a quintic. Again, not a vocabulary term we need to know, but just in case you're curious. We do need to know the leading coefficient. It's whatever's in front of x to the 5th, so that would be 2. Great. On to number 2. Evaluate with direct substitution first, then synthetic. And it's at x equals 2. So what we're going to do is plug in 2. That's what direct substitution means. This is the one we're used to. So we're going to plug in 8 times 2 plus 5 times 2 to the 4th minus 3 times 2 squared minus 2 to the 3rd. Remember, if that's a negative number, you do always want to put the negative in parentheses, but in this case, we don't have to worry about it. So then we do all that math. We get 16 here. 2 to the 4th is going to be 16, so it's 5 times 16. 2 squared is 4, so minus 3 times 4, and then minus 8. Notice that that negative is outside the parentheses, that's why it stays negative. Then we can keep simplifying this, so 16 plus 80 minus 12 minus 8. We get 96 minus 20. That would be 76. Now let's see if we get the same answer by synthetic substitution. So we're going to draw out our synthetic substitution format. And then we're going to put 2 up here in the corner, and then we're going to put our coefficients. First thing we want to do is put all our leading coefficients in order. So we want this in descending order from highest degree to lowest degree. So we're going to rewrite f of x with the highest degree first of 5x to the 4th. And then I want x to the 3rd, so negative x to the 3rd. And then I go to x squared, that's minus 3x squared. And then I go to x plus 8x. And then I don't have anything for my constant, plus 0. Okay, now let's put all our coefficients in. 5, negative 1, negative 3, 8, and 0. Again, those are the leading coefficients. That negative 1 is invisible. Then we perform our synthetic substitution. So the first thing we do is bring our 5 down below the line, and then we do 2 times 5 to get our next value of 10. And then we bring down negative 1 plus 10, and that would be 9. And then we do 2 times 9, that's 18. And then we bring down 18 minus 3, 15. And then we multiply 2 times 15, that gives us 30. 30 plus 8 gives us 38. And then we do 2 times 38, that is 76. And then we do 0 plus 76, that gives us 76, which is exactly what we got with direct substitution. So we did that correctly. Number 3, sketch the graph of a polynomial function which has an odd degree and a negative leading coefficient. So let's remind ourselves what polynomials look like. The most basic polynomial we can think of is y equals x. That has a positive slope, and it has an odd degree of 1. We know that if we have a negative leading coefficient, the graph is going to be sloping downward. And then the other most basic polynomial we can think of is x squared. That's a happy parabola. And then we have negative x squared. That would be a sad parabola because it has negative leading coefficient. Now, sketch the graph of a polynomial which has an odd degree and negative leading coefficient. So it's going to look most like this one. It could be that, but most likely it's got a few more bumps in the graph. So we're actually going to have something curving downward. It's got a few bumps throughout. We'll put it on the x and y axis. So this is what the basic sketch would be, because we don't know the degree. All we know is that it's odd, the ends point in opposite directions, and negative, meaning it's sloping downward. It's going down over time. Next, write end behavior statements. So for this one, we need to look at the highest degree, which in this case is negative x to the 8th. That's all we care about because the rest of these are insignificant compared to x to the 8th. That's the one that's changing most rapidly. So if we think about what this function is doing, it's going to act like a sad parabola because it has a negative leading coefficient and an even degree of 8. Close, just like 2 is even. So then we're going to draw out that picture, and that's going to help us with the end behavior. Now, it might have some bumps in the middle, but we don't really care. All we care about is the end behavior. So we know that as we go to the left, as we go toward negative infinity, so negative infinity is this way, the function is going to go down. We can see that it's pointing downward. So g of x, the function, will go to negative infinity too. And then if we go to the right, so if we travel all the way to the right to positive infinity, what is the actual function doing? It's going down to negative infinity. So again, the end behavior goes to negative infinity. Next we have polynomial addition. So we're just going to add like terms go ahead and find all of the similar degrees, add them together. We have 2x cubed plus 3x cubed, that's 5x cubed. We can also add 2x squared and negative 4x squared, that gives us negative 2x squared. Then we can add our x terms, negative 3x minus x, so negative 4x. And then plus 5 minus 7 would be minus 2. So that one's pretty straightforward because it's just addition in the middle. So we don't really have to worry about the parentheses. When we have subtraction though, we do have to distribute this subtraction to every single term. So we're just going to rewrite it without parentheses to make this a simpler problem. So now we have 3x cubed plus 4x squared minus 7x minus 12 minus 4x cubed plus 2x squared, the sign changes, minus 5, the sign changes. Now we can add like terms. So 3x cubed, negative 4x cubed becomes negative x cubed. The x squareds go together, we get plus 6x squared. Do the rest on your own. Negative 7x is by itself. Negative 12 minus 5 becomes negative 17. And that's our answer. Box in your answer. Okay, let's go to the back. We have polynomial multiplication. So now we know this is multiplication because we have nothing in between these parentheses. That means we're going to have to FOIL. So even though we have 2 terms and 3 terms, this is just like FOIL. We're going to make sure every term in the first parentheses touches every term in the second parentheses. So we're going to distribute x to everything in the second parentheses. Let's write that out. X times x squared minus 2x plus 3. And then we're going to do everything multiplied with negative 5. So minus 5 times x squared minus 2x plus 3. And now we can distribute, finish that problem, and combine like terms. So now I can combine my x squareds. I get x cubed minus 7x squared, and then add the x's together, we get 13x, and then minus 15, and that's all we can do. That's our answer. Next we have 3 binomials. Ooh, this is just like FOIL, but we're going to do it twice. So first we're going to combine the first set of parentheses. So we're going to do FOIL. First, outer, inner, last. First terms would be x squared. Outer terms, 2 times x. Inner terms, negative 3 times x. And last terms, negative 3 times 2. That would be negative 6. And now we want to multiply it with x plus 7. But before we do that, let's clean it up a little so we can make less work for ourselves. So we're going to combine like terms here. 2x minus 3x becomes negative x. So we have x squared minus x minus 6 times x plus 7. And we're going to do the same process that we did in the last problem. So take every term in the first parentheses multiplied by every term in the second parentheses. So I'll start by showing x squared times x. That's x cubed. X squared times 7, that's 7x squared. Then I want to do minus x times x, that's minus x squared. Minus x times 7 gives us negative 7x. And then we want to do the third term. Minus 6 times x gives us negative 6x. And negative 6 times 7 gives us negative 42. Now we can combine like terms. Our final answer is x cubed plus 6x squared, and then negative 13x minus 42. Box in your answer. Okay, last thing we have is a challenge problem. Also, there's some special product patterns here if you want to look over them. It's not a great idea to memorize them, but it is something to have in your toolbox. So mn minus 6 cubed. A lot of us want to jump to, say the answer is m cubed, n cubed, minus 6 cubed, whatever that is, 216. This is not your answer. It's not that easy. We're actually going to have to FOIL. So we're going to write this out literally 3 times. mn minus 6 3 times. That's what exponents are. They're repeated multiplication. So now we're going to FOIL just like we did in the problem above. We're going to FOIL the first 2. So we get m squared, n squared for the first term. Outer terms are minus 6 times mn. Inner terms are minus 6 times mn, same thing. And then last terms are plus 36. And then we want to bring down this mn minus 6 to multiply with our new polynomial. Now, this is not very pretty, so we're going to clean it up again. Put together the 2 negative 6 mn's, you get negative 12 mn. Now we have 3 terms and 2 terms, we can do our distribution. So first we're going to do m squared n squared times everything in the second parentheses. M squared times m is m cubed. Remember, you add exponents when you're multiplying terms. N squared times n is n cubed. These are invisible exponents of 1. And then we do minus 6 times m squared n squared. And then we go for the second term. So negative 12 mn times mn gives us negative 12 m squared n squared. Negative 12 mn times negative 6 gives us positive 72 mn. And then we do the last term. 36 times mn and 36 times negative 6, which is negative 216. So now combine like terms. M cubed, n cubed is staying by itself. And then we can combine these m squared, n squared terms. So these go together. And we get negative 18 m squared, n squared. And then we can combine these mn terms. So 72 and 36 make 108. And then minus 216 stays by itself. Box in your answer. Thank you. Don't forget to like and subscribe.